we'll deal with it later. Now, it shows up in a couple different places. It shows up in lesson 12.3, so the one that we would be covering after. And it also shows up in lesson 0.12. Remember, 0 is the chapter that came before our book started. And it was basically kind of highlighting things that you should have learned through 8th grade math. But some of you didn't get the 8th grade math all the way because you took the blended class, and the blended class kind of picked and chose which 8 standards to take. So, but box plots are very important, and actually of all the statistical things to use for analysis, it's the simplest one to do. So, box plot. And we'll do more with it next week. So today's date's the 20th. So the box plot is a visual representation of a set of data. And we have lots of these that I could use the same exact definition. We have dot plots, we have line plots, we have stem and leaf plots, we've got the box plot, we've got bar graphs, histograms, all sorts of ways to show you statistics, okay? Each one has something slightly different that it focuses in on, okay? So it's a visual representative set of data. It is a graph and a number line. Okay, so the number line is giving you reference to what certain points are in your data. Okay, now the box plot is based on 5 key numbers. Okay. So I'm going to list them as I would put them into my box plot. First, there is the least value. That's the first thing that you see on any box plot. Next, you have something called a lower quartile. I'm going to abbreviate it LQ because that's what I'm used to, but I think the new abbreviation is Q1, okay, for the first quartile that shows up. Next number you're going to see is going to be the median. It is referred to as quartile 2, but more often it is just called the median. Then you have what's called an upper quartile, which is referred to as Q3. And then the last piece of information is the greatest value. Okay. So, what's median? What's the median? Yeah, it deals with the middle. But here's what's important. It's the middle of data organized, bless you, from least to greatest. Oh my goodness, bless you. There's another one. I heard that coming up. Tiana, I think, holds the record of like 12 in a row when she was a baby. She sneezed all the time as a baby, but I couldn't believe that little thing. It's like, how are you breathing? Oh, there's another one. Is that air conditioning kicking his way? When we do medians, our numbers need to be in order from least to greatest. That's why I just, every time I see data, I organize it from least to greatest, because there's so many different things that I need to do that rely upon the numbers being in order from least to greatest. I'll have a hard time finding median if I don't do that. In fact, it'll be impossible. I'll have a hard time finding mode because I'll have numbers scattered all over instead of like numbers right next to each other. So what lower quartile is really the median of the first half of data. And that makes the upper quartile the median of the second half of data. So the order that I listed them is the order that they appear, but let me write down the order of how you would find them. You start with your least and your greatest, and you need your median. You cannot figure out what the first half is until you figure out where the middle point is. Once you have where the break is for the half, then you're going to find the median of the first half. Everything's already in order from least to greatest. It's really easy. The worst case that you have to do is add two numbers and divide by 2. So you find the median, or the mean of two numbers. And because you're dividing by 2, it's really easy to take half of a sum. So then I would find the lower quartile and the upper quartile. Okay, next. When I use that word quartiles, what does that sound like to you? Quarters. And that comes up as why this is important. So that is supposed to be a number line. It doesn't look real pretty. So your number line will have numbers. So 1, 2, 3. And it could be any set of numbers. It would only be integers. It could be, I would say we wouldn't see negatives, though I guess it would not be impossible. And then you're going to see 5 values. So we have one value, another value. Now let's see our blue value. And our upper quartile. And our greatest value. Okay, so labeling. I like to call this LV for least value. We'll call this guy Q1. We'll call this guy M. The next guy is going to be our Q3. And then here's our greatest value. So you're like, okay, I get the 5 dots, but where's the box? Okay, what I do is I take my 3 medians and I create a box with them. How? I just draw vertical lines through my 3 quartiles, and then I combine them into the box. So the median of the overall data is always in the box, okay? And in the old day, we called this box and whiskers because we would attach the least value to the box and the greatest value to the box. Now, because these are described as quartiles, what that means is it represents 25% of the data. So, for example, let's say I had 16 numbers, and I have 4 quarters, 4 quartiles. How many numbers would be in each of those sections? I heard somebody say something, but I couldn't quite hear it. Yeah. So there would be 4 numbers here. There would be 4 numbers here. There would be 4 numbers here. And there would be 4 numbers here. Now, the question is, if each one of those sections, those quartiles, represents the same amount of numbers, how come they all aren't the same size? Okay. Jake?
Because the numbers inside can be scattered around.
That's right. The range of the numbers inside of each of those groups may be large or small. So for example, look at from the median to quartile 3, it was a very small section. That meant the 4 numbers could have been like 7, 7, 8, 8, very close to each other. Okay, in our case it would, yeah, between 7s and 8, so that was good. I didn't even look there. And then notice how big we've got for the greatest value, okay? And we may have an 8, a 9, a 10, but we've got this 13 out there. So what the box and whiskers plot, the whisker part, is really kind of accounting for outliers. So our focus becomes the box. And what I believe Mr. Mason said that you guys were doing last year is you would put 2 of these together, analyzing 2 different sets of data and comparing their medians and so on and so forth. So this has actually got a very broad range perspective, and it's funny because when I taught it for the first time, I'm like, what the heck, I've never seen a box and whiskers plot in my life. And then I realized this is a really good way to talk about average. Okay, so homework is going to be the rest of the exemplars, and we'll talk more about box plots next week.